Find all zeros of the polynomial x cubed plus 4x squared plus 10x plus 12. We'll start out the problem by using the rational zeros test. What this says is that any rational zero must be of the form q over p, where q is the factor of the constant term and p is the factor of the leading coefficient. So if we look at the set of all possible answers here, we have all sign combinations of 1, 2, 3, 4, 6, and 12 divided by, so those are all the factors of the constant term. The only factors of the leading coefficient, which is 1, is 1. So this gives us a list that's plus or minus 1, 2, 3, 4, 6, and 12. So these are our possible rational zeros. To see if we can cut this list down, let's use Descartes' rule of signs next. For this, we're going to count the sign changes. So if we look first at the positive real zeros, we want to look at how many of these we could have. We're going to count the number of sign changes in the original polynomial. This starts out positive and it stays positive all throughout. There are no sign changes. And since there are no sign changes, that says that there are no positive real zeros. Since there are no positive real zeros, that says the only zeros we can have are the negatives. So we're going to get rid of this and look at just negative answers. That's good. It cuts our list in half. Now to actually find these zeros, we're going to have to do a little bit of trial and error. And we'll do this with synthetic division. So since we've ruled out the positive answers, I'm going to try -1 for starters. And then we'll set up our division bar and write in the coefficients of the original polynomial. 1x cubed plus 4x squared plus 10x plus 12. So we take our leading coefficient and slide that down, and then multiply. -1 times 1 is -1. And then we add these together. This gives us +3. And then we multiply. -1 times +3 is -3. We then add these together, which gives us +7. Then multiply. -1 times 7 is -7. And if we add these together, we get a remainder of +5. Remember, this last corner entry is the remainder. And since this is not 0, this tells us that x equals -1 did not work. That x equals -1 is not a zero of this polynomial. So x equals -1 didn't work. Let's try going on to the next one. Let's try x equals -2. So we'll take -2 and we'll do the synthetic division process here. And again, we write in the coefficients of the original polynomial and then go through the process. We carry down the leading coefficient and then multiply. -2 times 1 is -2. Adding these together, we have a +2. We then multiply. -2 times 2 is -4. Adding these together, we have +6. We then multiply. -2 times 6 is -12. Adding these together gives us a remainder of 0. That's good. This says that x equals -2 is one of our zeros. And it also reduces the degree of the remaining polynomial. The original polynomial was degree 3. After doing this successful synthetic division, our new polynomial is degree 2. So if we write this polynomial out, x squared plus 2x plus 6 equals 0. We want to find all the zeros, so we set it equal to 0. And now we could, in theory, either factor this or use the quadratic formula. Since I don't see a way to factor this, I'm going to start out with the quadratic formula. This is x equals -b, or b in this case is 2, plus or minus b squared, which is 2 squared, minus 4 times a times c. A is the coefficient of the x squared term, which is 1, and c is the constant term, which is 6. And this is all divided by 2 times a. If we simplify this, this gives us -2 plus or minus the square root of -20 over 2. Now that square root of negative 20, there's a few things we can do to simplify it. First off, I see that it has a negative in the radical. That tells us that this is going to be imaginary. Second off, 20, we can simplify that to 4 times 5. And 4 is a perfect square. The square root of 4 is 2. And the 5 will be left over inside the radical. And then finally, we can reduce each of these to give us negative 1 plus or minus I times radical 5. So now we have our three zeros. We have x equals negative 2, x equals negative 1 plus I radical 5, and x equals negative 1 minus I radical 5. We have three zeros, and the polynomial was degree 3, so we know we found all the zeros.